Now, we'll look at the patent document of interactive battery charger for electronic vehicle published on 13 January 2022. You can see different components of the patent document marked on your screen. To understand what these documents mean, you can refer to our previous course on how to read a patent and its importance in the world of innovation. Now, we'll start with the abstract. The abstract of this patent document says that the present invention addresses the pressing need for electrified transportation to mitigate the negative impact of petroleum based vehicles. One of the major hurdles in transitioning to electric vehicles is the long charging times, which need to be reduced to 5 to 10 minutes in order to compete with traditional vehicles. To tackle this challenge, the invention proposes an intelligent EV charging system that incorporates advanced technologies. The system takes into account the limitations of the power distribution network and the lack of smart meter devices, ensuring balanced and efficient EV charging. It utilizes fast charging experiences, whether data processed through advanced algorithms and simulation techniques to optimize the charging process. Additionally, a mobile application is developed to provide EV drivers with real time assistance and enhance their overall charging experience. Further, the invention leverages vehicle to grid technology, enabling a bidirectional connection between EVs and renewable energy sources within smart grids. This integration allows for the exploration of new paradigm of electrical markets. Their electricity production and consumption can be optimized. By embracing this approach, the system aims to create favorable conditions for the commercialization of electricity and maximize the benefits of renewable energy sources in the context of electric vehicle charging. Next is the field of invention. The field of invention says that the invention is related to an interactive battery charger for electric vehicle. Now, we look at the background of the invention. The invention is an interactive battery charger designed for electric vehicles. The background of this invention stems from various challenges, including power quality deterioration, disruptions in power supply, distribution transformer issues, distortion, and high fault currents. To mitigate these problems, an economical solution is proposed, which involves integrating renewable energy sources into the EV charging infrastructure. In recent decades, there has been a gradual shift from petroleum based transportation to electric based alternatives across various sectors, including crafts, trains, ships, and EVs. This transition is expected to continue advancing rapidly, especially in the case of EVs, due to their numerous benefits and political incentives. The decreased costs and increased production have contributed to the growth of electric vehicle market. However, considering that the world's oil supply is projected to last until around 2050, it becomes imperative to develop alternatives to fossil fuels for transportation and electricity generation. EVs are recognized as a viable solution for transportation and are increasingly being accepted as technology evolves and becomes economically feasible. They offer higher energy efficiency, improved fuel economy, and reduced emissions and pollution, especially when powered by renewable resources like wind and solar energy. Furthermore, EVs enable greater fuel diversity for the United States, as a significant portion of its electricity generated from domestic sources, including gas, coal, nuclear, and renewable energy. However, this new reality also presents additional challenges such as potential overload of the voltage distribution network when multiple EVs are charging simultaneously, managing home consumption and contractual power limitations, and optimizing electricity purchase at low costs, then there is excess renewable energy generation and selling electricity at higher prices when demand exceeds supply in the electrical network. One solution to address these challenges is the implementation of smart grids, which involve measuring devices, a communication infrastructure, and other devices. Smart grids can help managing power distribution based on historical data and play a significant role in resolving these issues in the near future. The proposed system, integrated within a smart grid, can also perform tasks related to energy management, such as identifying the optimal hours for charging or discharging EV batteries and handling other personalized home functions effectively. Next, we look at the objective of the invention. It says that the interactive battery charger for electronic vehicles has several objectives. Firstly, it aims to address the negative environmental impact caused by the dominant use of petroleum based transportation, promoting a shift towards electrified transportation. Secondly, the invention seeks to overcome technological challenges, especially in developing fast charging technologies to make electric vehicles more practical and accessible. Thirdly, it strives to significantly reduce the charging times for EV batteries to compete effectively with conventional transportation options. The system is designed to handle electric vehicles charging intelligently, taking into account the limitations of electric power distribution network. By using smart meter devices, the charging process can be balanced based on past experience and weather information obtained with data mining and simulations. To assist user and facilitate mobility, a dedicated mobile application is created to guide electric vehicle drivers during the charging procedures. Moreover, the smart electric vehicle charging system incorporates vehicle to grid technology, connecting EVs and renewable energy sources to smart grids. Lastly, the system explores the new paradigm of electrical markets with electricity production deregulation, aiming to optimize the commercialization of electrical energy and promote sustainable practices. Next is summary of the invention. The invention focuses on maximizing device efficiency by reducing its size, weight, and cost through integrated topologies. These topologies involve reusing certain drivetrain components such as inverters and motor windings for the onboard charging system. However, challenges arise from its integration, including difficult access to motor windings and need for proper arrangements during different operations modes. Furthermore, controlling the active switches becomes more challenging with this charging configuration. The General Motors EV1, one of the early mass produced EVs, had different charging capabilities. Over time, charging technology has improved. For example, the 2018 Chevrolet Bolt has three charging options: basic charging with a 120 volt outlet, fast charging with a 240 volt option, and super fast charging with DC charging. While EV driving range have become competitive with traditional combustion engine vehicles, recharge times still lag behind. Standardization of charging ports has become a necessity as electric transportation has grown. However, the lack of charging port standardization remains a significant hurdle for EV adoption, as different manufacturers use different configurations. Efforts by organizations like the Society of Automotive Engineers aim to establish industry accepted standards. During the charging process, a layer of charged conductor material grows, slowing down the charging rate, while increasing the applied overpotential could restore faster charging rates. There is limit to how much overpotential can be applied. Exceeding this limit can damage lithium ion batteries due to undesired chemical reactions. The proposed investigation involves applying various technologies such as software development, Web 2.0, geographic information systems, mobile computing, and wireless communications to emerging smart grids and electric vehicle fields. The goal is to develop a mobile application and closed system that assist users in the EV charging and discharging process and provide support for participation in electrical market. This application will help users navigate the complexities and options of the charging process, enhancing their overall EV experience. Next, we'll look at description of drawings. The drawing shows a system for an interactive battery charger designed for electric vehicles. The system incorporates various modules to manage the charging process effectively. Sensible grid interface module. This module handles the interaction between EV and electrical grid. It ensures stable energy flow and manages electricity cost variations to optimize energy trading with the grid. User Manager Module. The User Manager is responsible for registering users and their EVs. It allows users to input and modify their information, and it also verifies users' identities and vehicle ownership. It keeps the user database clean and prevents spam. Profile Manager Module. This module stores different load profiles for each registered vehicle. Users can define various charging schedules based on their needs, such as different profiles for weekdays and weekends. Manager Central Module. This is the main module of the Smart Electric Vehicles charging system. It interacts with all the other modules mentioned above and manages the distribution of system information. The overall system aims to create an intelligent charging system for EVs that connects them to smart grids. It uses vehicle to grid technology, allowing EVs not only to charge from the grid but also feed back excess energy to the grid when needed. In simpler terms, the drawing depicts a smart charging system for electric vehicles, which interacts with the electrical grid and allows users to manage their charging preference effectively through different profiles. It also enables a two flow of energy between the EVs and grid, promoting efficient energy utilization. I hope this module will help you read and understand patent documents better. Also, check out our free course on how to read a patent document and its relevance in the world of innovation. Thank you.